Recording in progress.
Just picked up your voice. All right. Okay. Anyway, system of equations. Really simple. I'll write a little note here. A system of equations is simply two or more equations with two or more variables. That's all it ever is. It's a system. So it's got multiple equations, multiple variables. For today, our focus will be on linear equations. Remember, linear equations are like y equals mx plus b. That's gonna be our focus. You could do systems of quadratic equations, like parabolas, and they're touching like multiple times. You can do lots of different systems. We'll venture down that path when we learn about those functions in the next few months. For now, let's keep it very simple. We did linear equations in chapters 1 and 2. That's what we're going to do in chapter 3. By the way, the solution to a system of equations is simply the point of intersection. Because if you think about it, what if you have two lines? If you have two lines, what's going to happen? There are three things that could happen. Go ahead. Here you go. They could intersect. So that's one possibility, right? So the point of intersection is going to be the solution because that's common. That point is common to both lines. Whatever x and y is over here, that's going to make both equations happen. However, it's going to always happen. What else do you got could happen? Unless they're parallel. They can be parallel. What if I had this here? Are these two lines touching? So unless they're parallel, in which case we're going to say no solution because there's nothing in common, right? Or there's one more scenario that could happen. That's not terribly obvious, but maybe someone might know. No, they would intersect. They're perpendicular. The slopes would be very specifically related, being negative reciprocals. But what if the two lines are? Yeah. Yeah. Or they're the same line. In which case you're going to say infinitely many solutions because they're intersecting a whole bunch of places, right? So those are the three scenarios you could have. The last two are quite rare, but could happen.
Would we say infinite solutions or all real numbers?
Great question. So if I can ask a fantastic question. You're not going to say all real numbers because, like, obviously where my finger's pointing right now, that's not a point on the two lines, right? You're going to say infinitely many because there's so many that you can't count. But it can't be all real numbers because it's not everything. There is a situation where when you solve a linear equation, I know what you're thinking of. You think of this like this. So if you have like 2 times x plus 2 equals 2x plus 4, I'm trying to solve that, right? If I were to do that, here's what's going to happen. They're identical on each side. In that case, that's all real numbers. Because any number I could think of would make that work. And that's just one equation, right? But these are a little different. We have two lines that superimpose each other. They're just intersecting at several points, but not any point you could think of. So you just say infinitely many for that. But great question. All right, so we'll solve it. We'll see it. So you guys know how to graph. That should be pretty simple. -2 is right here. Slope of 3. Another slope of 3. Then we get a straight edge here. Okay, I think I did it kind of straight. Kind of messed up a little bit. See if I can rotate that.
And don't worry if your lines are not too straight. Do your best. So that's the first line. And remember, y equals mx plus b, slope, y-intercept. Next up, 5x plus 2. You have that. You have a slope of 5. That's off the grid here. Okay, I think I know where they touch. Feeling pretty confident about that. Let me make an adjustment. All right. I think I've got it.
Okay, where do you think they're touching? Good, excellent. Love it.
They're touching at -1, -3. Great. Now, how do we know for sure? Yeah, go ahead. Oh, hold on. I'm wrong then. Ah, hold on. You are correct. And why am I wrong? To have a y-intercept of -1. Is my y-intercept off? Yeah, this is kind of okay. This is good. Okay, this is good. I'm glad I made a mistake. Because is this a very accurate method? Probably not, right? Okay, so -1, -3 actually does not work because if I plug into both equations, it doesn't make the first equation happy. It makes the second one happy, but not the first one. So yeah, so it looks like I kind of goofed with my green line. So let me okay, let me do the green line again. I'll be really quick. Uh-huh. Yeah, I see right here. They actually don't touch. Ah, there we go. Okay. Yeah. I know, very exciting, huh? All right. Here we go. Okay, now were they touching? -2, -8, yeah. Okay, and then what you want to do is test. If you test it out, does -8 equal 3 times -2 minus 2? Yep. And check the other one. Does -8 equals 5 times -2 plus 2? Yep. That checks out. So we know it works. However, it's not a terribly accurate method, as you just saw.
Personally, if I were asking you to do this on a test, I'd probably make one of these slopes negative. So it goes the other direction, and it's a little more obvious where they'll touch. When you have two positive slopes that are pretty close together, it's kind of hard because they're almost parallel some ways. So not the best example, but just to show you that, yeah,
It's not a terribly accurate method. Now, you could put this in Desmos, real easy. If you go to Desmos really fast, if I go y equals, I already forgot. What were the equations again?
For number 2.
No, number 1, 3x minus 2.
5x plus
3x minus 2, and thank you, y equals 5x plus 2. All right, let me clear my screen. If you want, yeah. The cool thing about Desmos,
it gives you the answer straight up. You just click on where they touch, boom, gives you the answer right there. That's very nice.
the graphic calculator does the same thing. I'll walk you guys through the graphic calculator stuff on Friday because I want to make sure we have enough time for the programming project today. So yeah, that's that. Now let's go keep moving. Now number 2, we'll do this one quickly also. This shouldn't take too long. What you need to do, we don't need to do it this way. What I would recommend you do is isolate y. You could do that too. We'll talk about that on the next page. Yes, I would agree that's a better option, Hugo, but we'll do it this way right now. I know you guys can do that. Not hard. Let's change colors. Let's go 8. And if I plug in 1, I get 4. Plug in 2, I get 0. Let's do a straight line. And let's adjust that just a tad. Come on. There we go. Let's go green for the other one. 1. Down to, if you plug 1, you get -1. Plug in 2, you get -3. Plug in 3, you should get, wait. There we go. Plug in 4, you should get -7. All right. Yeah, I think so. Yeah, it should plug. Is that right?
I didn't
Okay, actually,
with the limited. I got.
do you get decimal?
4.5.
Okay, so it's hard to tell. Yeah, I'll say it's hard to tell. So if I go to Desmos again, now the cool thing about Desmos too, this is the other advantage that Desmos has over the graphic calculator. You don't have to isolate y. You can type in the equation as you see it. That's kind of a neat thing about Desmos. So if I were to do 4x plus y, yeah, because as I was doing it, like I didn't feel comfortable with my answer. 2x plus y equals 1. Clear my screen. Look at that. 3.5 -6.
How are we supposed to tell that by graphing? It's really hard to tell, right? Like that's why graphing is not a very accurate method. We were pretty close when I said like 4 -7, but no, if I were to ask yourself like graphing, make it more obvious. I'd make it more obvious.
We're going to talk about that. We're going to talk about that in the next page. You're talking about substitution. We're going to get there. All right, let's keep moving, guys. Okay, now, yeah, Meredith, yeah, go, yeah. Now, here's the deal. This next page, on page 3 of these notes, I would recommend you do them algebraically instead. Algebraically is a better way to go because it's more of a guarantee to get the answer. Now, you have 2 ways you can do it.
I don't care which way you choose. In fact, actually,
No, it's fine.
okay, cool. Actually, I'll stick with the weakness. Anyway, so
Yeah.
most likely, next slide, please. Most likely, I'll ask you guys to do each way because I do want to see that you can do substitution like names and things. So I am going to try to force you guys to do one of each method. But for word problems or other times where I don't give you an option, you get to choose.
You get to choose. If I don't tell you what to do. If I just say just solve it, whatever you're comfortable with. However, sometimes some methods are better than others. Like in this case here, I probably would use elimination. And the reason why I'd use elimination is that if I add the equations, what's going to happen? If I add these 2 equations, what's going to happen? Yep. You get this. You get x equals -1/2. The y's cancel. The y's are eliminated. Once you know x is -1/2, it's kind of your call which one you want to plug it back into. If I plug it back into the first, again, it's your call. 5 times -1/2 plus 2y equals -2. -5/2.
These numbers all suck.
They do. They're not great. I know.
Like
They're kind of crappy numbers.
-0.5 and 0.25.
I think you get 1/4, if I'm not mistaken. Yeah. 1/4 sounds correct to me.
So -1.
Yep. Yeah, 4 and 4.
Again, the fractions can be a little nasty. Now, the good thing is that I will let you use the graphing calculator. I'm pretty sure, well, except for maybe the graphing part, that would not be a lot unfair. But definitely for something like this, I think I'd be fine with the graphing calculator. You have to show me the work, right? And also the graphing calculator, you can verify your work because you can graph both these equations. Again, I'll show you guys how to graph this in the calculator on Friday. So I really want to make sure you have enough time to get to the program. But you could graph this to verify your work. So that's elimination. Any questions on elimination, how it works?
What's the other technique you can use too? Yeah, substitution. Now in this case, probably substitution is a little better because y is isolated. If you want to do elimination, go ahead, but you'd have to get everything on one side. I mean, sorry, when I say everything, all the variables on one side, the constants on the other side. But I'd probably do substitution. I'd probably say this 5x. And from my experience, my students seem to like substitution better than elimination. I will say this substitution is probably more foolproof.
I forget.
You substitute. That's why it's called substitution.
You replace the y. So y is really isolated the second equation, right? You simply replace that y with what this equals. Hence substitution.
All right, got it.
It's like for example, I'm gone after 14th. I'm gonna be home. Someone's gonna come in and substitute, right? Someone's gonna replace my bird.
Yeah, I just
Yeah, that it's just replacing. That's all. And then you guys have solved these many times, right? I mean, this is just a linear equation. It's not that hard. Yeah, these numbers suck. Yeah, I promise you guys, I'll give you guys numbers that don't suck. I'll try to give you guys integers as answers. I promise you that. But these numbers do kind of suck. And then plug back into one of the other equations, work it out. Not too hard. What I did, and I know we'll also know the fraction. So if you're having total fractions, exactly AJ. 1 is 3 over 3. And we add 3 over 3 negative 16 over 3 get negative 13. I'll back up. I'll back up. I'll back up. Let's back up a little bit. All right.
No, I
Okay, so we got negative 16 over 3, right?
You add 1, so it's 13. Okay, I got that.
You good? Cool.
Yeah,
No, it's other.
Okay. Okay, first off, are you guys cool with red? 4/3. Are we cool with that? We're cool with 4/3. Okay. Now, once you got x, throw it back into any equation you want. I threw it back into the second one, because y is already isolated. If I throw it back into the second one, I have this. Now, what's negative 4 times 4/3? That's negative 16/3. Because whenever you have a whole number or an integer times a fraction, negative 4 is like negative 4 over 1, right? Just multiply the numerators and denominators together, you get negative 16 over 3. And 1 can be written as 3 over 3, right? Because isn't 3 over 3 still 1? And you have the same denominator. The whole point, you got to find an LCD, a least common denominator. I know I glossed over, so I apologize for doing that. But ultimately, by the time, in the next couple of years, when you do get the calculus, you do need to make sure that we can be more fluid with our fractions, right? So because we're, a little bit slow crossing the fractions, just make sure we have a whole number. Try and match it with the denominator. Okay. And actually, if you want, the calculator is pretty cool because you could do this in the calculator. I could say negative 4 times 4/3 plus 1. The calculator does order of operations for you automatically. And if you want to make that a decimal, go math, frac. There you go. I think Ms. Holman showed you guys yesterday. You get math, first off, frac. First need decimal, as long as it's a rational number, to a fraction 4. If you want, you could. So, all right, let's keep moving. I'm gonna skip this problem. Let's skip number 5 for now.
What? No. Wait, so if you get, I did
You graphed it?
algebraically, well, I graphed that as well.
Mhm.
Algebraically, if you get, like whatever, 2x minus 5 equals to negative,
Absolute value of x. Mhm.
you do go with the two values. Right?
Yeah.
But then, cause then I got
But you'll have to check your work though afterwards.
x equals to 2. Would I go with the whole number?
What was that?
Would I go with the whole number? If I get.
Well, no, I mean, both answers could be valid, but you have to check both of them. We'll talk about it on Friday. So we'll skip 5 for now. Okay. Number 6. Okay, you don't have to discuss with a partner. We'll discuss as a class. Guys, quiet down, please. Thank you. We'll discuss as a class. So for number 6, will two linear functions always have an intersection? No. Because you could have this. Or you could have this.
Oh, I just should check for x, which one's closer to the actual graph. Right?
What do you mean closest?
If I graph them.
Oh, yeah, right. Right. Now, will the system always have a solution? No. Could be no solution. Guys, stop it. All right. No solution. If two lines are parallel. Yeah, so doesn't always have to have a solution. If two lines are parallel, be no solution. And how many intersections can a linear function, absolute value function have? We'll just talk about this really quickly. They could intersect twice. That is weird. There we go. Could intersect twice.
They can also not intersect. This line could be directly below, or they can intersect just once, depending on how that line is situated. We'll talk about number 5 on Friday, because number 5 is kind of like part C of number 6. So we'll explore that on Friday, because I really want to see folks.
Could you technically have an ancient number because it's like.
Yes, they could. That's a great observation, Diego. Yes, they could. It could be this also. It could be infinite also. So that's yet another possibility.
Could be infinitely many solutions as well. That's yet another scenario. We'll explore this more on Friday. So I want to keep moving.
Also, they never touch. They can have just one solution. The 2 would be like this, like that. Yeah. But let's just keep moving. All right, word problems. We're gonna skip number 2 because you put a strike through it. Let's look at number 1. Okay, so this is a very simple calculation, which most of you guys probably do in your head or just bust out your cell phone and use the calculator on your cell phone. But let's say you take the train every day, and let's say you use a train because are you use a train every day? Probably not.
I mean, it depends if you're
On Sunday, you can come to school.
no better because of data.
Okay.
5 days a week.
Okay, let's say
Students, so.
you use a train 30 days in a month.
$48.
Okay. So use it 30 days in a month. Okay. So the monthly pass would just be like this. The one-way pass would be like this. Where X would be the number of days.
So it's pretty clear that we had travel 30 days. We're talking 30 here. Which one's a better deal? in one-way passes, you 30, by 30 one-way passes, multiply monthly pass. Monthly pass would be better. Yeah. Monthly passes.
How they get you.
And also, if you think about graphically, that could be like y equals 42.4. And that could be like y equals 1.6x. So ultimately, they're going to intersect somewhere. Actually, let me get a calculator and see what it intersects.
And if they intersect before 30 days, then
Well, the thing is, you're not gonna use.
Yeah, they intersect about 26.5 days.
5 days a week.
Yeah.
Every week in 20 days, and you still have 2-3 days to get what you want.
So if you took the train 26 times, that's right. If you ride the train 26 times in 1 month, then you probably better off getting the 1-day passes.
Oh,
But
but
if you
it's
do
one
27
way.
or more times in a month,
Oh, wait,
it
but
is
it's one way.
one way.
it's one way cost.
It's twice, it's 2 times a day.
It's actually a one way. Actually, ooh, that's right.
Ooh. Now the
Oh,
monthly pass looking
So
a lot more
like
worth
13, it's
it.
13 days is the top sheet. So it's a monthly pass.
Monthly pass.
oh, good observation, Hugo. So actually, come to think of it now, that's 26.5 times. So that means that for 13, because you're doing probably 2-way, right? In 1 day. Yeah,
That's
Uh, true. Okay.
Here you go.
Okay, let's do the next one's a little more realistic. Let's look at number 3 and 4. Okay, 3 and 4.
What is silk spring t-shirt?
I don't know.
What is silk spring?
I have no idea. I don't make t-shirts, so you're asking the wrong guy. All right. Here's the deal, guys. There are 2 things we don't know. What are the 2 things I don't know? What are 2 things I didn't know in this problem?
The number of t-shirts.
The number of t-shirts of each. So let X be the number of long sleeve shirts, and let Y be the number of short sleeve shirts. So now, this is the
Part that some people feel a little apprehensive about, but you guys be fine. You gotta make 2 equations, 2 variables. With information in the work problem, I'm gonna make my equations. What do you guys think?
You have to find out cost.
Just lose the student money.
The gross revenue is like $3 a shirt. That's for shorts. 5 for long sleeve.
Oh, right, so that's the cost. Well, that's what we spend. Okay, got it.
So if you're making 5 for long sleeve.
okay. So here's where you spend. Okay, let's do this, guys. Actually, I didn't quite read the problem carefully.
Nobody says how much you spend.
Right, right. So here's what we're gonna do. Yeah. The beauty about Zoom is I can color code it like this, right? So you're gonna need 2 equations. One for the cost and one for the sales. For the cost, how are you gonna make that equation? Thank you. 5x plus 7y equals 2,500. How about for the sales? Perfect. Thank you, guys. So
The important thing with work problems, a lot is gonna come down to executive functioning in many ways. You have to organize your thoughts. Realize that, okay, wait a sec, the 5 and the 7 go together, because that deals with cost, as well as 2,500. 8 and 12 and 14 are about to go together, because that has to deal with sales, right? Once you have equations, you guys can solve it.
Like y plus 2 or whatever.
was that sorry?
Like if you're just trying to solve what the cost, you go y x plus 2 and then you just put that.
Y equals that. Y y equals x plus 2.
Because y is $7. Oh, wait, no.
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 All right, here's what I want you guys to do to practice. Solve the system of equations. Use elimination, use substitution, whatever you guys like. I don't really care. I think elimination actually I would probably do elimination. I'd probably do elimination. Yeah.
Yeah.
If you do elimination, I'd probably multiply this by -8 and probably multiply this by 5.
Yeah.
The reason why I do that
Is that the x's would cancel? You probably need a calculator. Go ahead and solve it, see what you guys get, and then we'll check in about 1 minute.
Oh, -8 and 5.
Yeah, I'll do -8 and 5. That way the x's would cancel.
I'll do it down below here.
Wait, why is it JK and why?
Okay. Glad you're kidding. Gosh, that's a pretty big number.
Oh my. That's a lot of people.
So we are just gonna find the y.
Yes, right now we are. That's, geez, 21 thousandths.
I got y equals to 116 over 1,000.
What do you get, Hugo?
116 over 1,000.
116 over 1,000?
I got 116 over.
I get y is 250. We'll see what you did wrong, Hugo. Give me a sec.
Oh, you can.
Yeah, I agree. You see what you did wrong, Hugo?
I actually don't know. Well, I didn't know the calculator.
I know that.
But what's it times 8 on these?
And that should be
2x.
12, 150 for x. Is that right?
Oh, I didn't. So I added the y's instead of I added the y's. That's why.
I kept that.
I kept the y as a positives instead of using the top one negative. That's what
Yeah, so watch out for Kale stairs. Okay. Cool. We're okay with this? It's good. Review. Okay. Did you get 250 for y? Whoa.
Yes, I did.
All right, good. You got 2 for y. Okay, good. Which one do you play back into?
I looked at back in 5 plus 7x equals.
Oh, you have it mixed up. 5x plus 7y. Unless if yeah, it should be. Well, what is your x represent?
My x represents.
Yeah, okay. It should be 5x plus 7y equals 2,500. Try a little bit reverse.
So x is 150.
Yeah. All right, we're gonna keep moving, guys.
Big brain.
Let's do one more word problem, and then we'll look at linear inequalities after that, and then we'll talk about the program project. All right. Okay, number 4. There were 76 tennis players at the regional girls tennis tournament, and actually, you know, the more I think about it, after number 4, let's do the calculator stuff after this. Linear inequalities, I'll save for Friday because I can do it on Friday. I think this is a little. Yeah, I think it's a little too much for me to do 3.3 today. Let's do 3.3.2. We'll do 3.3 on Friday. What was that? We're doing 4, and then after that, we'll do the calculator stuff.
Yeah. All right, you guys. This project, sorry, this problem here. Go and set it up. Do it on your own. You guys have 2 or 3 minutes. Let's see if you guys get the right setup. Solve it. We'll check in about 2. I'll do it as well. We'll see if you'll see an answer. We'll get a report up.
Let's give this next one a shot. Just to help you out, Lizzie, you have a question? Some help? Okay, so whenever you guys are stuck, I always ask stuff, what are you trying to figure out, right? They're asking how many games of each kind. So we'll say X will be the number of single games. That means like singles players.
I don't know. Put two of the same equations. No.
For those who are watching US Open, you know, they have singles and doubles, right? Singles is one against one person, doubles is 2 against 2, right? Well, hold on a sec. There are 26 games,
Oh,
right? And then a singles game, how many players plays in singles, guys? 2. You have 1 on each side of the net. How many players in a doubles? 2 on each side of the net. And 76 players involved, right? Now solve. And actually, I probably do substitution.
I probably isolate X or Y. By the way, when you use substitution, I strongly recommend that you isolate the variable that won't create fractions.
But isn't that pretty easy to use?
Elimination too.
Elimination, that's good.
That's good. But I'm just saying, if you're getting substitution, make sure you isolate the variable that won't cause fractions. So that makes it easier to do that. So we could use you could choose X or Y, your choice. Let's say it's X by itself in the first equation.
If I do that, I'll switch colors for contrast. Then you say X equals 26 minus Y. Then you come back down here and you replace X with 26 minus Y and solve for Y. If you so desire to solve that way. And if you do, I'm just going to do all the steps in my head, which is not, I don't recommend that. I recommend you work things out so you get credit. I think I got it, but I could be wrong.
Oh, okay, I got you.
I could be wrong. I could be wrong.
So I didn't try a little.
I'm wrong. I'm wrong. Guys, I'm wrong. This is why you don't, yes, it's 12. This is why you don't do it in your head. That's why you don't do it in your head. Yeah, it should be 12 and 14. Yeah.
Yes. That's an idea. Yep.
Okay. Cool. All right. I feel we did a good review of system of linear equations. I think that's good. I don't want to overwhelm with too much information. You still got 3 other classes today. Let's now go back to the project. This is perfect time. We've got 24 minutes. Yeah. Good work there. All right. I'm gonna still keep the recording up. That way you guys can watch this. So if you, and I'll upload the recording later today. So if you want to like fast forward and don't watch the stuff we've done for the last 40 minutes and want to fast forward to the calculator part, that's totally cool. Actually, you know what? Let me be smart about this. Let me stop the recording, make a new recording.